All parabolas have either a maximum or a minimum value. So if your parabola opens up, again, that happens if your compression stretch is positive, right? Then you're going to have a minimum value, and that value is going to occur at y equal k, whatever the k value of your vertex is. If your parabola opens down, again, that's if a is less than 0, or you have a negative compression stretch, then you're going to have a maximum value that occurs at y equal k. And again, this is the y value of our vertex. Let's take a look at what this is talking about real quick before we do some examples. Well, again, what this is saying is A is positive. Well, my A here is positive, right? So that'd be opening up. So if I'm opening up, I have a minimum value. That means I have a smallest value for this parabola, and it's going to be whatever the K value for your vertex was. If my A is less than 0, so if I'm negative, my parabola is going to go down. And if I go open down, then I'm going to have a max or a biggest value. And again, that's going to be located at whatever the y value of the vertex is. All right, well, let's do some examples where we're finding min and maxes. So the next 3 problems are asking us to find the x-intercepts and the min and max value of the following functions and to graph it. Well, how do you find x-intercepts? Well, again, find x-intercepts the exact same way we found them with transformations of functions. You set the function equal to 0 and you solve it for x. So going along here, I have negative x minus 2 squared is equal to negative 4. Divide both sides by that negative to get rid of it, and I get x minus 2 squared is equal to positive 4. Well, in order to get rid of the square, I need to take the square root of both sides. I do that, and I get that x minus 2 is equal to, remember, if you take the square root to solve, you have to write plus or minus, and then we write 2. Well, these are all pretty numbers, so let's go ahead and separate this out. So I have 2 equations. One of them is x minus 2 is equal to a positive 2. The other one's going to be that x minus 2 is equal to a negative 2. So going along here, I get x is equal to 4 and x is equal to 0. So I have 2 x-intercepts and I have 0 and 4 or 4 and 0. Now you can write your x-intercepts like this. You can put them in braces like this. The only thing you cannot do is put both of those together in parentheses. That is wrong. So I just encourage you to leave it like that. 0 and 4, you're done. Just 2 numbers separated by a comma. It's also asking me for my min and max value. Well, that's easier to see once I've graphed. So let's actually graph this. Well, this particular function is already in standard form, which is great because standard form makes it so easy for us to graph. Again, let's find the vertex. So the vertex is HK. H is your horizontal shift. What's the horizontal shift here? It's right 2, which we know is a positive 2, comma, k. What's my k value here? It's 4, so I write 4. There's the vertex of this parabola. Well, what's the compression stretch? The compression stretch is equal to negative 1. So what does that mean? That means that from this vertex, I go down 1, 1 to the left, and back from the vertex, go down 1, 1 to the right. I also know that I have the points 0 and positive 4 on this graph because I already found those x-intercepts. So let's go ahead and plot them to help us graph. So connect all your points, and this is the graph of this parabola. Great, now I need to figure out, do I have a min value or do I have a max value? Well, take a look at the picture. Is there a minimum value? No, there isn't a minimum value because the smallest thing I get to are arrows. Well, infinity is more of a concept. It's not a number, so it's not a minimum because there's always something smaller than that. So I don't have a minimum value. Do I have a maximum value? I do. Remember, if a is less than 0, you're gonna have a max. So I only have a max value. So what kind of value I have? I have a max value. So I want to circle that because I want to reassure myself that, hey, I have a max value. And then I need to figure out where it happens. What happens at y equals a number? Well, the number that it's going to equal is whatever what k is. Well, what's k? Well, if we look here in our vertex, k was equal to 4. So we have a maximum value at 4. And if you look here, the y value of this dot is 4. Let's go to the next one. Again, I need to find my x-intercepts and I need to find my min and max value. Finding x-intercepts first. How do you do that? You set the equation equal to 0 and we solve for x. Well, again, this is a quadratic, so I can factor it. So let's go ahead and factor it. See, it would be x plus 7 and x minus 1. If I solve both of these, I get that x is equal to negative 7 and that x is equal to positive 1. So my two intercepts are negative 7 and positive 1. Well, now I need to graph it. Well, I don't know how to graph x squared plus 6x plus 7. I don't know how to graph this unless I have that standard form, or at least I know my vertex and my compression stretch. Well, how do I find my vertex? Well, we know how to find the vertex. First, we need to label a, b, and c in our given function. So then how do you find the vertex? You find the vertex by h equals negative b over 2a. Well, what is negative b? That would be negative 6 over 2. What's a? 1. Well, negative 6 over 2 is just negative 3. So the x value of my vertex is negative 3. What's the y value? Again, to find k, you need to find the function's value at negative 3. So if I plug negative 3 in place of my x's in my function, I get negative 3 squared plus 6 times a negative 3 minus 7. Going along here, negative 3 squared is 9. 6 times a negative 3 is minus 18 minus 7. Keep going. F of negative 3. 9 minus 18 is negative 9 minus 7 gives me a negative 16. So the y value, or the k for my vertex, is going to be negative 16. So again, my vertex is going to be this negative 3 comma negative 16. So let's graph that. Negative 3, negative 16. And I'm not going to make it, so I'm just going to make a random dot here. And what we're going to do is we're just going to call this negative 16. So didn't fit on the graph, not a big deal. Just call that negative 16 and we can just work with it. Well, what's the compression stretch? Well, the compression stretch is A. A is equal to 1. So my compression stretch is equal to 1. So that tells me from this point, I'm going to have to go up 1, over 1, up 1, over 1. And I also have x-intercepts. I have it at negative 7 and at positive 1. So I'm going to put those all on there. I'm going to graph my parabola. And there we go. Perfect. So now what do we need to do? We need to find out, do I have a minimum or do I have a maximum value? Which way does a parabola open? It opens up. When you open up, you don't have a max because up to the top of the parabola you got arrows, which means infinity, and you can't reach infinity. It's not a number. There is no max. But do I have a min? I do. When you open up, you have a min. Well, where do you have a min? Again, you want to circle that word min because you want to make sure that you know, hey, I have a min value. And where is that min? It's going to be at y equals some number. Well, the number it equals is, again, the k for your vertex happens to be negative 16 in my case. So this particular parabola has a minimum value at y equal negative 16. Okay, let's look at the very last example for this section. F of x is equal to 4x squared plus 12x plus 9. So, first, find my x-intercepts. I do that by setting the function equal to 0 and solving. Alright, so if we're going to factor this, it'll factor as, looks like 2x and 2x, and 3 and 3, and both are plus. So it looks like it factors as 2x plus 3 times 2x plus 3. So when I set the factor equal to 0, since it's not different, all you have to do is set one of them equal to 0. And you solve for x and you get x is equal to negative 3 over 2. So I have an x-intercept at negative 3 over 2. So again, if I would have solved it twice, I would have gotten negative 3 over 2 times. But negative 3 over 2 is the same number as negative 3 over 2, so I don't write it twice, I just write it once. I need to graph this thing, but that's in general form. I can't graph when I'm in general form, so I need to find at least my vertex. So how do I do that? I find h. Well, h is equal to negative b over 2a. So let's find out what h is. So it's the negative of b. Yikes, what's a, b, and c? Go back. A is 4, b is 12, c is 9. So negative b, so negative 12 over 2 times a, which is 2 times 4. Okay, so h is equal to negative 12 over 8. So if I reduce this, both divisible by 4, I get that h is equal to negative 3 over 2. Well, what's k? Well, k is always the function's value at h. So I need to find f of negative 3 over 2. So let's plug negative 3 over 2 everywhere there's an x in my function. So I say 4 times negative 3 over 2 squared plus 12 times negative 3 over 2 plus 9. Alright, so what is negative 3 over 2 squared? Well, negative 3 over 2 becomes a positive 9 over 4. Then I can put my 12 over 1. 2 goes into 2 ones. 2 goes into 12 6 times. 6 times a negative 3, negative 18 plus 9. Well, here my 4's cancel. F of negative 3 over 2 is equal to 9 minus 18 plus 9. Well, 9 minus 18 is equal to negative 9, and negative 9 plus 9 is equal to 0. So the vertex for this particular function is negative 3 over 2, comma 0. And again, if I don't know where negative 3 over 2 is, maybe it's worthwhile making it into a decimal. Negative 3 over 2 is negative 1.5, comma 0. All right, so let's graph the vertex. So negative 1.5, comma 0. So negative 1.5, 0, right there. And then I need to use my compression stretch to find my key points. Well, my compression stretch is 4, so I need to go up 1, 2, 3, 4 units, 1 to the left, and again up 1, 2, 3, 4 units, 1 to the right. There we go. This is the graph of our parabola. Now I just need to figure out, do I have a min or do I have a max? Well, again, my parabola opens up. If your parabola opens up, you don't have a max, you only have a min. Well, what value is my min at? It's always going to be at y equals some number. Well, what's the number going to be? It's going to be the y value of your vertex or your k, which is 0. So this particular function has a minimum value at y equals 0. That's it for quadratic functions.